So for problem 2.7, problem number 1, I am going to break everything down for you, okay? So we have some function of time that is our position function. So first, let's do part A. So part A says to find the velocity. So the velocity, if this is our position function, so that is just the first derivative of our position. So that's going to be 3t squared minus 24t. Oh, don't forget the plus 36. So that is our velocity. And so since our original position was feet, this would be in feet per second. So we've differentiated with respect to time, which was seconds. Now, part B says to find the velocity after 3 seconds. So part B, let's just take our velocity and plug in 3. So that's going to be 27 minus 72 plus 36, or negative 9 feet per second. So that's the instantaneous velocity at 3 seconds. Now let's look at part C. When is the particle at rest? So the particle is at rest. You think about that as where the velocity equals 0. So we're looking at that velocity problem from part A, where is 3t squared minus 24t plus 36 equal to 0. Well, it's factorable. So if you factor out a 3, you're left with t minus 2 and t minus 6. And so it has 2 places where the velocity is 0, at 2 seconds and at 6 seconds. So that's part C. Part D, when is the particle moving in a positive direction? So it will move in the positive direction when the velocity is positive. So if we think about that, we are thinking about where this function is bigger than 0. Now it's a parabola. It has zeros we just found in part C of 2 and 6. And I know that's a crude picture, but if we think about where it is positive, it's positive here and here. Now, time, we're not going to go backwards in time, so we're going to start at 0. So from 0 to 2, it's going to be positive, and then from 6 to infinity, it is going to be positive. So anything between 0 and 2, and then anything bigger than 6. We can include the 0 because that point is definitely a positive point. Okay. Now let's read the instructions for E. Find the total distance traveled during the first 8 seconds. Now let's think about something for a minute. It is traveling in the positive direction from 0 to 2, okay? So if we start at 0, so that's our original function I'm using. I'm calling it S sub, so you can think about position. If we plug in 0, we're going to get 0. So the starting position was 0. And at time 2, okay, it is going to have gone, let's see, at 2, it's going to be 32. So from time 0 to time 2, it has traveled 32 feet. Okay. Now let's see what's happening between 2 and 6. Okay. At 2, it was at 32, and then at 6, if you plug in 6, it's back at 0 again. So it has gone, in that time, it's gone backwards 32 feet, but it's technically gone a total of 32 feet. And then from 6, now we're looking in the first 8 seconds. Isn't that say first? Yeah, first 8 seconds. So it's at 0 at 6, and then at 8, it has gone another 32. Symmetry isn't a great thing. And then, so then it's going to total another 32. So if you add those all up, it went 96 feet total. So you kind of have to do the forward motion and the backward motion separately and think about them separately. Don't care about a diagram. Let's move on to G. Let's move on to G. Let me add myself a little bit of room here. Okay, G. Find the acceleration at time t. So if you look at our velocity function in part A, just take the derivative of that. So now that's the second derivative, which is 6t minus 24. That is our velocity function. That's after time t, and after 3 seconds, just plug in 3, and we get 18 minus 24, or negative 6 feet per second squared. So that's G. Oh, what's next? Okay, let's go back here. Don't care about H, speeding up and slowing down. This is kind of an interesting one. If the velocity and the acceleration have the same sign, it will be speeding up. If they have different signs, it'll be slowing down. So let's take a look. I'm going to use Desmos as our friend here. And let's put our velocity equation from part A in. Okay, so our velocity equation was, and I'm going to use x's. So 3x squared minus 24x plus 36. Okay. And then we're going to look at our velocity equation, which we found to be 6t minus 24? Yep, minus 24. Okay. I got to call it x, I'm sorry. Desmos will be confused. Okay. So what do we have to go? Well, if they're both above the x-axis, that means that they're the same sign, or both below the x-axis, they're the same sign. So let's compare the pictures for a minute, okay? So if we look at the red graph, that's our velocity. It is positive until 2, and then it's negative until 6, and then it's positive again, okay? So if we make a plus-minus chart, I'm sorry, this is going to be, so it's positive, negative, positive, okay? Now let's look at our acceleration. So our acceleration is the blue graph, and up to 4, it is negative, so here and here it's negative. And here it's above the x-axis, it's positive. So let's look, I'm going to highlight in yellow the places where the signs match. So between here and here, they are both negative, and from here to here, they are both positive. And then I'll highlight in green where they are different. So in the green region, our signs are different, so it's going to be slowing down. In the yellow sections, they are the same sign, so it is going to be speeding up. And so let's kind of describe that. And so we have to stop at 0. Okay, so it is slowing from 0 to 2, and then again from 4 to 6. It is speeding up from 2 to 4 and 6 to infinity. Okay? So kind of an interesting concept that if the velocity and acceleration are the same sign, it will speed up. If the velocity and acceleration are different signs, it is going to slow down, okay? Let's see if there's any other thing I want to do for you for number 1. No, that's it. So I hope that that helped you kind of think about those. Thank you so much for watching. You have a good day.